In this video, you're going to learn how to represent the electrons in an atom using two different types of notation. The first of which is called an orbital diagram. This is an orbital diagram pictured at the bottom of the screen, which simply means there's a series of boxes and arrows that illustrate where the electrons are found in this atom. Anywhere you see a box here, that represents an orbital. Recall that the 2p sublevel is made of 3 orbitals, so we've drawn in 3 boxes. Anywhere you see an arrow in this diagram, well, that represents the electron. Remember, if you're going to put 2 electrons into the same orbital, they must have opposite spin. So we draw one of the arrows pointing up and the other arrow pointing down. When students learn how to make orbital diagrams, they usually have a few questions, and I'm going to try to answer those now. The first question is, they want to know how many boxes should I draw on my paper? Well, it depends. If you're trying to represent an S sublevel, you should have 1 box drawn and labeled. If you're trying to represent a P sublevel, you should draw 3 boxes, labeling that a P sublevel. A D sublevel, of course, would have 5 boxes, and you probably already know how many an F sublevel has. That's right, 7 boxes for the F sublevel. The next question is, how do I know what order to draw all of these? How do I know what box to make first and next? And then is it a P sublevel or is it a D sublevel? And so I'm going to tell you how you know that. There's a list of sublevels. I'm going to give you this list right now, and I'm going to ask that you write this down. Go ahead and do that now. I'm going to wait while you pause my video and write this list down. It is essential when you're learning how to make orbital diagrams that you write these in the correct order. Now that's a lot to remember. That's why I recommended that you write it down. The third question is, when do I stop making boxes? How do I know when I don't have to keep drawing boxes anymore? And that's the easiest question to answer. You stop drawing boxes when you're done. In other words, when you've got a place for all of the electrons in whatever element you're representing electrons for, you can stop drawing boxes. Let's try one of these. We're going to draw the orbital diagram for fluorine. Now, when you're drawing an orbital diagram, you're going to need to look on your periodic table. We're going to look up fluorine on our periodic table and find it right over here. So the element fluorine, element number 9, should have 9 electrons, and that's what we're going to represent. Next, we're going to draw some boxes. Now on my paper, I've already got the boxes drawn, but on yours, you'll probably have to start from scratch and draw boxes. Remember the order you wrote down. It's the 1s that comes first, and then the 2s comes next. I'm going to start filling in electrons until I get to 9 electrons because fluorine was element number 9. Notice the way that I enter these. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the representation for fluorine. That was easy. Let's try another one. Next, I'm going to do the orbital diagram for magnesium. So I get out my periodic table and I look for magnesium. Magnesium is element number 12. So I'm going to draw 12 electrons. Sometimes when I'm drawing these, I'll write out the symbol and the atomic number so that I remember how many electrons I'm doing. Remember, the atomic number is the number of protons, but atoms always have the same number of electrons as they have protons. So 12 electrons will get placed like this. And that's the correct placement for the electrons in a magnesium atom. Let's try one more of these orbital diagrams. This one's a little longer. This is the orbital diagram for an element called selenium. Selenium is element number 34 on the periodic table. That's a lot of electrons. Let's not complain though. At least I didn't ask you for rutherfordium. So let's fill in some electrons for selenium. We're going to need 34 arrows. I want you to notice the way that I fill these in. First of all, I'm going to follow the off-bow rule and work my way up. Secondly, I'll always put 2 electrons in a box, 1 up and 1 down. And third, watch how these fill in. We like them to be half full before we completely fill each sublevel. Now remember, I'm drawing arrows until there are 34 of them. And if we do a quick count, we can see that so far, looks like we have about 30. So the last 4 electrons will all fill in the 4p sublevel. Sometimes I see this when students turn in their work. Can you see the mistake with writing an orbital diagram this way? That's right. We didn't follow a rule that says these electrons want to be spread out. Before we put 2 electrons in the same orbital, let's spread them out so that each orbital is half filled. I think we understand how to do orbital diagrams now.